14th problem. When 100 joules of work is done on a flywheel, its angular velocity is increased from 60 rpm to 180 rpm. What is the moment of inertia of the wheel? Okay, so there is a one flywheel and uh, its angular velocity or initial rotations is given, that is 60 rpm, and we are doing some work on flywheel, and because of that work done, the rpm, number of revolutions, are increased to 180 rpm. Then what is the moment of inertia of the flywheel? Okay, so from this, first what dot first the given data write down here. Work done is given 100 joules. Okay, so work done W is equal to 100 joules. Okay, then uh, initial rotations is given, that is initial rotations is nothing but n1, and that is equal to 60 rpm. Okay, so this is, we have to convert this into uh, in seconds. Okay, that is equal to 60 rotations per minute. Minute means nothing but here 60 seconds. Okay, this is rps. Okay, so this is our it is equal to revolutions per second is nothing but it is also frequency, that is equal to 1 edges. Okay, or one number. Okay, so then per second it is making one rotation. Okay, then second one is n2. After we are doing this work, then this number of rotations are increases. How much it is increases? That is n2 is given here 180 rpm per minute, 180 revolutions, and this is equal to per second 180 rotations per minute, means that is 60 seconds. So it is rps. Then 1010 cancel, 6 3s are 18, so that is 3 revolutions per second, or 3 edges, angular frequency or angular velocity. And this is also angular frequency or angular, sorry, and number of rotations and number of rotations. Okay, so from this, omega 1 is equal to 2 pi n1, and that is equal to 2 pi n1. Okay, so 2 pi n1 is equal to, that is n1 is equal to 1, and it is equal to 2 pi radians per second. Okay, that is omega 2 is equal to, and this is 2 pi into n2, number of rotations, and that is equal to 2 pi into 3 radians per second, and that is equal to 6 pi radians per second. This is the omega 2 and this is omega 1. So initially the angular velocity is 2 pi radians per second only, but after applying this work done on that, and it is increased to 6 pi radians per second. Okay, so by doing this work done, angular velocity is increases. So there is a change in angular velocity. Change in angular velocity is nothing but change in kinetic energy also. When velocity is changes, kinetic energy changes. So from work energy principle, from work energy principle or theorem. Okay, so that is work done W is equal to change in kinetic energy, change in kinetic energy, and that is equal to change in kinetic energy. It is a rotational motion, so rotational uh, change in kinetic energy in rotational motion. So that is 1 by 2, or kinetic energy, final minus kinetic energy initial, and that is half into I into omega f square. F means here omega 2 square minus half into I into omega 1 square. Initial kinetic energy, final kinetic energy, and that is equal to work done. So from this, work done W is equal, in both of them we have a 1 by 2 I is common, then this is equal to omega 2 square minus omega 1 square. Okay, so from that it is equal to, this is 100 joules of into I. So that is we want to find out here omega 2 square. Omega 2 is 6 pi. It is 6 pi whole square minus omega 1 is equal to 2 pi, and this is 2 pi whole square. Then it is equal to this is 100 into 100 is equal to half into I into this is 36 pi square minus 4 pi square, and that is equal to 32 pi square. Okay, so and from this I is equal to 2 into 100, that is 200 by 32 pi square. Okay, this is 32 pi square, and it is equal to 200 by 32 pi square is equal to 3 pi is equal to 3.214, and its square is 9.8, and that is equal to, after solving this we got the answer is 0.634. This is 0.634 kg meter square. This is moment of inertia when rotations changed from 60 rpm to 180 rpm.